proper connection made between these two, right. So, if everything is right, it will work as an AND gate, but sometimes during manufacturing certain things may go wrong. Okay. See, you need the alignment of masks to produce a structure like this. Okay. Oxide, right, then polysilicon, then source, drain. Okay. So, to produce this structure, the masks must be correctly aligned, etc. But if they are not, this guy can extend well within, right, and this it is possible that it will be permanently conducting. Okay, this will always conduct. Okay, so the channel is always formed. Okay, or because of misalignment, it may turn out that you can never turn on this guy. The channel will never get formed. Okay, so there could be such defects. Okay, or maybe this is there is a metal contact here and there is metal brought out here, right, and it is possible that this metal got shorted to either the VDD or the ground. Okay. So, if you see how they do the layout of this NMOS transistor, this could be one way, right. So, they will draw diffusion layer, okay, and then they will draw, let us say, the this is the P diffusion and this is the N diffusion. Okay. And then maybe there is a polysilicon, okay. So, when I did this, what essentially has happened is there is a PMOS transistor like this, okay, and similarly there is a NMOS transistor like this. Okay. The two gates are connected because it is the same poly running across. Okay. So, this A and this A are connected, this B and this B are connected. So, that has happened. Okay. Then I may put a metal contact here, okay, and see, this is that VDD point. So, I may call this VDD. Okay. Then VDD, let us say this is A and this is B. Okay. So, we have VDD, then this is that output point. This is the output point. Okay. And this is again VDD. So, we have to short these guys together. So, we run it in metal. So, all this is metal. So, we have been able to form this, okay. VDD out, there is a transistor, VDD out, there is a transistor, and the two outs are connected. So, I essentially have so this is the structure I have created. So, there is a PMOS VDD, then VDD again, and these are connected together, and this is VDD. That is what you see here. There is VDD, this transistor out. So, I have opened this whole thing. On the other hand, here this may be my out, and this may be my internal point X and this may be my ground point. So, there is a contact here between end diffusion and metal, and this out and this out should be connected. Okay. So, this there is already metal here, so I may have to run around like this. Okay. So, I have connected the out to out, okay, and this should go to ground, and this is the output, this is the VDD. Okay. Let us say this is how it is been implemented. Okay. I have mentioned earlier to you that there are what are called as DRC rules, design rule check rules, design rule check. And I believe I mentioned to you that there are width rules. Okay, this is the width of the PMOS, I am sorry, the poly, that should have a minimum value, otherwise it will not come out correctly. Similarly, the width of the metal line must be having a minimum value. Similarly, the separation between this metal and this metal must have a minimum value. Now, these two metal lines are happening in the same layer, right. So, there are two metal lines which are going next to each other, and if DRC is violated somewhere here, there is a good chance that they will get short circuited somewhere here. Even if DRC is fine, okay, even if DRC is fine, what could happen is, see, how do you think this pattern is formed, right. So, when they want to do the metallization, the entire area is covered with metal, right, and wherever you do not use the metal, that is in that area you will remove it, the metal. Okay. You will remove the metal wherever you do not need it, okay, by an etching process. It is a chemical process by which you will remove the metal. Then there is a good chance that it will possibly remove insufficient amount of metal, and as a result there is still a contact between this metal and this out. Okay. As a result, VDD and out could be short circuited. So, there could be a short circuit between VDD and out, or the out is maybe disconnected, it removed too much material. When removing this metal from here, it also removed metal from this and out became open, this connection never happened. So, this connection does not exist. So, out is directly connected like this. So, many such defects could occur. So, these are called defects, okay, these are physical defects. So, let us look at the first situation where the two metal lines got connected, okay. The out line and the VDD line by mistake they got connected. Then what will happen is VDD will, the output will always be at logic 1. Okay. So, we say output is stuck at 1. So, this will happen if there is a defect which causes the two metal lines to get short circuited, or if the metal line gets open, if this line becomes open, then there is no connection between the these two lines, its out is directly coming, like it has been implemented like this. This connection has not been. So, if that happens, obviously output will get stuck at 0, okay. It will never become logic 1. Okay. Similarly, if A is permanently on, okay, because of the way the transistor came out, the channel is permanently present and as a result this is always on, then again output will always be turned on. Right. So, physical defects lead to faulty gates.